Can resonance really collapse a building? Imagine standing near a tall glass of water and tapping it gently. Sometimes a small tap can cause the water to ripple, but other times, a certain rhythm makes the water splash out. This is similar to what happens with buildings and resonance. Now, you might wonder, can this effect actually make a building fall down? Let's find out. Resonance happens when a force causes an object to vibrate at its natural frequency. Every building has a natural frequency based on its size, shape, and materials. If external forces like wind, earthquakes, or rhythmic loads match this frequency, vibrations can grow stronger. When vibrations get intense enough, they can weaken the structure or cause parts to break. A famous example is the Tacoma Narrows Bridge in 1940. Wind caused the bridge to sway wildly because the winds first matched the bridge's natural frequency. The oscillations grew bigger and bigger until the bridge collapsed. This event showed how powerful resonance can be in causing structural failure. Buildings can also resonate during earthquakes. The ground shakes at different frequencies, and if those match a building's natural frequency, the building can sway excessively. Taller buildings tend to respond to lower frequency ground motions, while shorter ones respond to higher frequencies. If the shaking continues long enough, the vibrations can cause parts of the building to crack or even collapse. Engineers work hard to prevent resonance disasters. They do this by changing how a building responds to external forces. For example, they might add damping systems like tuned mass dampers, which are big weights that absorb vibrations. They also design structures to avoid matching the frequencies of common external forces by adjusting the stiffness or mass of the building. In some cases, engineers use base isolators, special bearings that allow the building to move independently of the ground during an earthquake. These measures help keep vibrations in check and prevent resonance from causing damage. So, resonance can indeed cause a building to collapse if external forces match its natural frequency and vibrations become too strong. That's why understanding and controlling resonance is a key part of making buildings safer. By designing structures that resist these vibrations, engineers can stop resonance from turning into a disaster.